Good evening, everyone. Welcome to the one problem per day or one concept per day portal. And this question is on electricity, which helps you to understand the relationship between EMF, internal resistance, terminal potential difference, and so on, which are the very basic things in order to solve any kind of problem. This question is taken from 2005 May paper, which was for the HL tz1 over here. Okay, now let us start with this question. A dry cell has an e.m.f. E and internal resistance R and is connected to an external circuit. There is a current I in the circuit where the potential difference across the terminals of the cell is V. Okay, so there is a current I and the potential difference across the terminals of the cell is V. Which means what? You are connecting this one to, if you connect a voltmeter over here, you find this would be your TPD. What is TPD? Terminal potential difference, which is equal to V. Okay, now state expressions in terms of E, V, R and I where appropriate. You can use all the standard values for the total power supplied by the cell. What is the total power supplied by the cell? So whenever you are speaking about the total power supplied, you say power is equal to voltage multiplied by current. What is voltage here? Voltage of the cell. Voltage of the cell is capital E, which is the EMF. Don't write V here. Okay, it is capital E because V includes the voltage drop across the internal resistance also, which we are not going to consider. So this is E, and what is the current passing through it? The same current I will pass through it. V into I. So therefore, this is your total power supplied by the cell. Okay, now let us move on to the next one. The power dissipated in the cell. What is the power dissipated in the cell? So where does the power get dissipated? What do you mean by dissipated? Dissipated means the power is getting lost, right? So does the power get dissipated in the battery? No, definitely, because it's a reservoir of the energy. So it does not get dissipated there, right? It is getting generated because of the reactions, with the chemical reactions that are happening over there. Now power can get dissipated over here. Okay, what is the power dissipated here? I can say if I is the current passing through it, I square times R will be the power dissipated over here. So thus I can now write this as I squared to R. What is the power dissipated? The external circuit. What is the external circuit? The circuit which is apart from the cell is external circuit. What is the external circuit? Only a resistance R over here. So therefore, if I is the current passing like this, then the power dissipated here would be I squared multiplied by R, right? So therefore, I will write this as I squared into R. Now use your answers to derive a relationship between V, E, I and R. Okay, so we need to derive a relationship between terminal potential difference also. Now how do we do it? Now what we do is, let us consider the total energy, a total power dissipated, a total power given by the cell, supplied by the cell, EI is equal to I squared into R plus I squared into capital R, right? So this is the total energy given, and this is what has been dissipated across the internal resistance and as well as the external resistance. Now I can also write, this can be written as I squared into R plus V into I. What is V here? V is nothing but the terminal potential difference which is observed between this point and this point, right? So a current I passes over here. This doesn't have any resistance. This is the same as this point also because they are connected in parallel. So therefore, I can now say this is V multiplied by I is also equal to I squared into R. I can write like this also here. So as a result of this, what I can do is, I can now write like this. So I will now take common I over here. I will write V into I is equal to I into IR plus V, right? IR plus V. So this I and this I goes away. So E should be equal to IR plus V. So what is being asked? So he is asking you to relate the values of V, E, I and R. See, all of them are here. Okay. So thus we are able an expression over here. Now let us move on to the next one. Next, the graph shows below the variation of V with I for the dry cell. Remember, this is not a VI graph for the resistance over here. This is not for this. It is about VI graph for the cell over here. Okay. So what is happening inside the cell? We are going to connect a voltmeter here. We are going to put an ammeter somewhere and then going to do it. Okay. Now, the graph shows the variation of V with I for dry cell. Now, complete the diagram to show the circuit that could be used to obtain the data from which the graph can be plotted. You need to complete the diagram. How do you complete the diagram? So to do this particular graph, what do you need? You need the value of V and you also need the value of I. So what do we do here? You connect a voltmeter here parallel to this. and you need to complete the circuit. Only then current will move. You need to put an ammeter over here, and then you are going to put a resistor over here, and you are going to connect it like this. And then this resistance would be a variable quantity. Hey, how do I know? Okay, this and this is okay. How do I know that I need to vary the value of R? If you ask me this question, see, if I do not use this resistor, okay, then what will happen? Only the same current will be flowing over here. So you cannot vary the current. Is there a need to vary the current? Of course, there is a need to vary the current. See here, the voltage is varying, current is also varying. How do you vary it? You can vary it if you want to vary this one. See, there is no variation here. Same battery is being used. So the other way to vary is nothing but varying the resistance over here. You vary the resistance, definitely the current passing through this will vary, and when current is varying, definitely voltage will also vary. Okay, so you need to think like this logically how to arrive at it. Right, now let us move on. So use the graph to explain your answers. Determine the e.m.f. of the cell. Find the e.m.f. of the cell from the battery, from the graph given there. From the graph given. Okay. So what is the definition for e.m.f.? Okay, e.m.f is nothing but electromotive force. Okay, but how do you define it? You say that when the potential difference across a cell, when it is disconnected from the external circuit. Okay, you can say like this, or very simply you can just say that the current through the battery is equal to 0, then whatever voltage you see there, that is nothing but e.m.f. So as a result of this, now go back to the graph over here and find out where is the current 0. See, current is 0 here. Okay, current is 0 at this point. Now find out what is the voltage corresponding to it. Don't put 0 here. Answer is 0. Answer is not 0. The voltage corresponding to it is nothing but that line intersects this point. See, look at the coordinate here. The coordinate here is nothing but x comma y. X is equal to 0 and y is equal to 1.5. Right, 1.5 volt. So which means what is x equal to 0? Current. And what is y? Voltage. Voltage is equal to 1.5 volt. So as a result of this, now you see the e.m.f. here is nothing but 1.5 volt. Okay, I'll write it down if you want. I equal to 0, e.m.f. is equal to 1.5 volt. Now let me come back to this. Mention this. That this for 2 marks. You need to describe it. Okay, in the graph at I equal to 0, V is equal to 1.5 volt. Therefore, e.m.f. E is equal to 1.5 volt. You have to mention this. Then, determine the current in the external circuit when the resistance R of the external circuit is very, very small. Okay. What is the current in the external circuit when the resistance R of the external circuit is very small? Now, let me go back here. When can what will be the least value of the resistance? The least value of the resistance could be 1 ohm, or maybe 0.1 ohm, or maybe 0 ohm. Okay. So something like when the resistance here is 0 ohm, then what would be the current passing through the battery? This is the question. Okay. Now let me go back here. The current would be maximum. Okay. But you need to get it from the graph. If the values of the components are given, you can easily do it. But here components are not given. You need to get it from the graph. Let me reduce this so that I can draw a graph properly. Okay. Now, so what I should do? Whenever the resistance becomes 0, that means what? The external current will become maximum. See, the current is now limited until here because there is some amount of resistance over here. So what I will do is I need to pull this one backwards, extrapolate this one here. Maybe if I use a scale, I would have got it better. It will come somewhere over here, and maybe come like this. Yeah, I think this is fine. Okay, so don't consider this. I will remove this. It's not getting removed. Anyway, okay, now it's removed. Okay, so therefore, what is this value? 1.3 volt, right? 1.3 amperes. 1.3 amperes. Does the current there? Determine the current in the external circuit when the resistance. So I is equal to 1.3 amperes. Now this is for 2 marks. So how do you write? You should not just write like this over here. Okay. So now what you do? Okay. When R is least, I is max. 1 mark. Then extrapolate the line to touch the x-axis, and this is your I max, which is equal to 1.3 I max. That's it. Okay. Next, let us move on to the next one. Deduce that the internal resistance R of the cell is about 1.2 ohms. Resistance, internal resistance. Now what do we do here? Now let us go back here, find out what is the slope. If you find the slope, what is that you get? You get the voltage across the battery and current passing through the battery. Okay, both of them are referring to the battery. So therefore, you get the resistance that is inherently present in a battery, right? Which is internal resistance. So towards it, what you do is, you have a graph here. Now why did I say slope? Because the unit for resistance is ohms, which is nothing but V by I, right? So it should be voltage by current. So here your voltage and current over here, you take the slope, okay? You are going to take the ratio of these two. So towards it, now you see, take the length of this. Look at the length over here. Length is around so much big. What is it? How much over here? So this is around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 and up. Nearly 10 boxes, for example. So when you take the slope, see to it that it should cover at least 50% of the line length. It should cover at least 50% of the line length. Okay, so you're not going to measure anything, just we have counted over here. So take a bigger slope. That's what I meant to say. So therefore, let me take up value somewhere over here. Take some point over here. Let me take up value here. Let me take up value here. And here, let me choose this particular value. This particular value. Okay, you can choose abruptly, but I have chosen these two. Okay, because a straight line, you should always get the same slope. Now you see, I have drawn this one over here and drawn this one over here. Okay. Now what we do is, let us write down the coordinates. What is the coordinate here? This coordinate here is, this coordinate is 0.1 ampere. X is 0.1 ampere. And what's the value of y? Is 1.3. This is around 1.36, 1.38. 1.38. Okay. Then, now let us come back here. So this value, once again, 0.1 ampere. And this value is 0.6. 0.6 volt. And this value, what is this value here? This value x coordinate is, where is it touching? It is touching over here. 0.7, 0.74, 0.74. Let me rub this and find out what is the exact value. It's touching midway over here. Okay, it's touching midway over here. So therefore, okay, it's touching midway over here. So I can say take this as 0.75 amperes and voltage is going to be 0.6 voltage over here. Now what should I do? I will now label these parts. I will say this is my A, this is my B, this is my C. Okay, you need to show all these calculations, only then you will get appropriate marks. Okay, now AB is equal to how much? AB is equal to 1.38 minus 0.6. 1.38 minus 0.6. How much will this be? This will be 8. 13 minus 6 is 0.78 volt. Okay. Now what is BC? BC here, right? BC is now equal to how much is it? 0.6, 0.75 minus 0.1, 0.65. 0.75 minus 0.1 is equal to 0.65 amperes over here. Let's take this 8 over here. 13, the other side. Okay. Now I want to find the slope. What is the slope here? Slope is equal to AB divided by BC, which will be 0.78 divided by 0.65 voltage by current, right? So when I do this, 0.78 divided by 0.65, it is 1.2. 1.2 unit ohms. So we have got this value. What is this now? Internal resistance. Let us take this value 1.2 ohms. Okay. So this is for 3 marks. Don't just write so much over here. You should write, okay, slope is equal to delta V by delta I. Substitute the values. Okay. You can say from graph. From graph, you can write down the values over here. Then you calculate this value and finally you say R is equal to so much. Okay, fine. So this is your 3-mark question. Then the maximum power dissipated in the external circuit occurs maximum power. Okay, when the resistance of the external circuit, resistance, what was the resistance? R, has the same value as the internal resistance. We already found out the internal resistance, R equal to R. In fact, this is called the maximum power transfer theorem. Okay, calculate the maximum power dissipation in the external circuit. So what we do is, we know we want to find out the P max also. So how do we do? So now we have I. What is the value of I? I is equal to V divided by R plus R. Total voltage by total resistance. What's the value of V? We have already calculated the value of V, right? It's already given. How much was the value of V? 1.5 volt, right? 1.5 volt, or e.m.f here, 1.5 volt divided by, what was the value of capital R? 1.2 plus 1.2, which should be equal to how much? 1.5 plus divided by 2 into 1.5, which should be 1.5 divided by 2.5. Let us use our calculator to get to know what is that value. It should now be 1.5 divided by 2.4 will be 0.625. Your current here is 0.625 ampere. Okay. Now, if I take this value, it is nearly 0.63 amperes. Okay. Now, what is the power? P max is equal to I squared into R, right? So, which should now be equal to, don't take 2R here. Okay. You are going to find out what is the maximum power dissipation in the external circuit. In the external, what is there in the external circuit? Only that resistance R over there, right? So, you should only take this value of R. This small r is hidden inside the battery. Okay, do not take that. So this should now be 0.63 square multiplied by 1.2, which will be equal to, how much will this be equal to? 0.63 multiplied by 0.63 multiplied by 1.2, which is 0.47628. 0.47628 you get. Let me check my PC to see what I have got. 0.63, and okay. So this should nearly be equal to 0.48 watt. Unit is watt over here. The answer is 0.48 watt. You should get an answer similar to this. Okay. So thus we have come to an end to these problems. So before you leave, do like, share, comment, and subscribe to my channel so that every day you will be able to see more number of problems, and it also helps the YouTube algorithm to help me out. Okay, so that it will show you more number of problems to you. Okay, thank you.